So, what if the next giant leap for AI isn't about making it smarter, but about making it wiser? Today, we're diving into a really fundamental shift in how we think about artificial intelligence. It's a way of building machines that teaches them to be cautious, to actually understand their own limits, and, ultimately to be a whole lot more trustworthy.
Just let this question sink in for a second. An AI that makes a mistake, that's one thing. But an AI that's dead wrong and shouts it from the rooftops like it's absolute fact with zero doubt, that is where things get really, really dangerous. And that's the exact problem we're going to unpack here.
You see, the problem really starts with something you could call the certainty illusion. A lot of the AI models we use every single day are built to give us one single, definitive answer. And that creates this false sense of security that can get us into a lot of trouble. Okay, let's make this real. Imagine an AI helping a doctor. A traditional model might just spit out a flat diagnosis. This patient has disease X, period. But a Bayesian AI does something way more useful. It gives a probability. It says, hey, there's an 85% chance it's this, but also a 15% chance it could be something else. It quantifies the uncertainty, and that gives the human expert the vital context they need to make a smart final call. This habit of hiding uncertainty is just a huge liability in any high-stakes field. I mean, think about it. Medicine, finance, a self-driving car trying to figure out a tricky intersection. In any of those cases, a single best guess with no idea of how confident the AI is, well, that's just a recipe for disaster. We need AI that actually knows the limits of what it knows. So, how do we fix this whole mess? Well, we have to teach our AI to think in a totally different way, to embrace probability. The solution is rooted in a framework that's actually been around for centuries, but it's now powering a massive revolution in machine learning. At its heart, Bayesian learning is just beautifully simple. It's a method that lets a model start with some kind of initial belief, and then it just systematically updates that belief every time it sees new data or new evidence. It's a constant cycle of learning and getting better, which is, a lot like how we humans learn. And here's the absolute key difference. A traditional model is trying to find one single correct answer. But Bayesian learning, it treats the answer as a whole range of possibilities. It keeps this entire spectrum of beliefs about what could be right, and then it sharpens those beliefs as more data rolls in. So how does this belief update engine actually work under the hood? Well, it all boils down to a really straightforward three-step process that comes from a famous formula called Bayes' theorem. Okay, let's break this down. First up, you've got the prior. That's your starting point, your initial hunch. It could come from an expert or maybe some historical data. Then you get the likelihood. That's the new stuff you see, the fresh evidence. And finally, you combine those two and you get the posterior. And that's your new, updated, more informed belief. And the cool part? It's a cycle. Today's posterior becomes tomorrow's prior. What you get is a model that isn't just stuck in its ways, it actually adapts. The more data it sees, the stronger its beliefs get, and the more accurate its predictions become. It's a kind of learning that really mirrors how a human expert builds up intuition and knowledge over a whole career.
And this isn't just some abstract idea from a statistics textbook. Nope. The Bayesian approach gives AI some legit real-world superpowers, especially in areas where uncertainty isn't just a bug, it's a core feature of the problem.
Now, what we're talking about here is really a deep philosophical divide in statistics. The Bayesian way, as we've seen, actually lets you bake in prior knowledge and then gives you back a full spectrum of possibilities. The more traditional, frequentist approach kind of treats things as fixed, unknown numbers, and doesn't really have a formal way to use those prior beliefs. For messy, real-world problems, that Bayesian toolkit is just incredibly powerful. Think about medicine again. A Bayesian model can tell a doctor, look, there's a 70% chance this tumor is malignant, but a 30% chance it's benign. That allows for a much more nuanced decision. Do you operate now, or do you run more tests? It's all about providing actionable intelligence, not just some black and white answer.
Or take finance. I mean, markets are famously unpredictable, right? Bayesian models are a perfect fit here because they can take an expert's forecast as a prior and then just constantly update their predictions as new market data comes pouring in second by second. You get a system that's both informed by expertise and reacting to reality in real time.
And for a self-driving car, oh, this is absolutely mission critical. Is that fuzzy blob down the road a plastic bag or a kid? A Bayesian system can actually quantify its own confusion. If its confidence is low, it can just default to the safest possible action, like slowing way down. This is how you build autonomous systems you can actually trust. Now, this all sounds pretty amazing, I know. But this approach isn't some magic silver bullet. There's definitely a price for all this power. But the promise for the future of AI is just immense. The biggest hurdle, honestly, is that it can be slow. It just takes a lot of computational horsepower. Because instead of just finding one answer, these models are exploring a whole landscape of possibilities, and that takes more work. Plus, choosing that initial prior belief is super important. A bad starting point can throw the whole thing off. It really requires some careful thought. But here's the really good news. This field is moving at lightning speed. There's a whole ecosystem of software tools popping up to tackle these problems, making Bayesian methods faster, more scalable, and frankly, a lot easier for developers to actually use. That barrier to entry, it's getting lower every single day. And the future is just incredibly exciting. We're seeing Bayesian ideas fuse with deep learning, which gives us neural networks that can tell you how sure they are about an answer, and that leads directly to AI that's more trustworthy and explainable. Systems that don't just give you an answer, but can also explain why and how confident they are. So look, if you take just one thing away from all of this, let it be this. This is all about building a totally new kind of artificial intelligence. It's an AI that has a fundamental and I think critical form of self-awareness. It knows the limits of its own knowledge. And that really brings us right back to where we started. As we continue to hand over more and more of our world to algorithms, our health, our finances, our safety on the roads, the goal shouldn't just be to build an AI that's always right. The goal should be to build an AI that's wise enough to know when it just might be wrong.